Welcome back, dear students. Myself, Dr. Akshesha. We have started with chapter number 2. It's a sexual reproduction in flowering plant. In this chapter, we have finished 2 sessions, and in the previous 2 sessions, we have discussed a reproductive part of a plant, that is flower. We have discussed the different parts of a flower like calyx, corolla, androecium, gynoecium. Their individual units like sepal, petal, stamen, carpel that have been discussed. Here we have to discuss the sexual reproduction, their events and processes. So we have also started with a male reproductive part of a flower, and that is a stamen. We have seen the structure of a stamen, what are the characteristics of a stamen. We have also discussed the internal structure of an anther. We have also seen the structure of Megasporangium. We discussed a process called as Megasporogenesis, means a process of formation of microspore, and we have seen few characteristics of pollen grain. I just briefly revise what are the characteristics of a pollen grain, and then we will go ahead with remaining characteristics of pollen grain. Okay, students? So let's start with a pollen grain. I just briefly revise what are the different characteristics of a pollen grain. Pollen grain usually is spherical in shape with a diameter of 25 to 50 micrometer. Apart from this spherical in shape, there are also different shapes of a pollen grain. And what are the different shapes of a pollen grain? It may be oval, it may be oblong, or it may be a disc-like, etc. These are the different shapes of a pollen grain. If you see the surface of a pollen grain, the surface of a pollen grain may be either smooth or spiny. It looks like a particles of a dust. Usually it's a yellowish in color. The cell wall of this pollen grain consists of 2 layers. Cell wall, it consists of 2 layers. The outer layer is called as exine. The inner layer is called as interne. Exine is made up of organic material called as sporopollen. This is the most resistant material till date known. It is resistant to organic acid, strong acids, strong bases, and higher temperatures. The intine, the inner layer of cell wall, it's made up of cellulose and pectin. Inside the wall there is a presence of cell membrane. Okay, this cell membrane is surrounded to a cytoplasm. So this is a structure of a pollen grain. Now if you see the structure of a pollen grain, when it starts to grow up, it divides into 2 cells. One larger cell, one smaller cell. The larger cell is called as vegetative cell. The smaller one is called as germinative cell. The larger cell, vegetative cell, it is full of rhizofood material and it has an irregular shaped nucleus. The germinative cell, it is a smaller one and that floats in the cytoplasm of a vegetative cell. It has dense cytoplasm, okay, and a conspicuous nuclei is present into a germinative cell. In 60% angiosperm, the pollen grain is released at this stage, but in remaining 40% stage, the germinative cell again divides by a mitosis and it forms a 3 cell, one vegetative cell, and these 2 cells which are going to be produced, they are called as male gametes. Each one is haploid in nature. Okay, so this is a 3 cell condition: male gametes and 2 male gametes and 1 vegetative cell. So in remaining 40% of the plant, the pollen grain is released at 3 stage cell. Okay, so either the pollen grain release might be at 2 cell stage or it may be released at a 3 cell stage. We have finished this much. Now few characteristics of pollen grain that was remaining. So now let's discuss the other characteristic of a pollen grains. So what are the other characteristics of a pollen grain? Pollen grain might be causing allergy to an individual who are susceptible to it or who are affected by it. It may cause some respiratory disorders if it is continuously exposed. So the pollen grain, it may has a chances to develop the respiratory disorders like asthma, and it may develop a bronchitis. This may develop because they are smaller in size, 25 to 50 micrometer in size. They remain suspended in the atmosphere. When you inhale, the chances are that the pollen grain may go into your respiratory system, and they may lead to a respiratory disorders like the asthma and the bronchitis, or it may causes the chronic affliction to an allergy like of a conditions that might going to be developed by this. How this occurs, or which pollen grain are more susceptible to cause this kind of a respiratory disorders? The pollen grain which is obtained from a plant called as Parthenium or carrot grass. Clear? The pollen grain of this plant, Parthenium or the carrot grass, that is highly susceptible to cause this respiratory disorders like asthma and the bronchitis. The pollen grain of this Parthenium or the carrot grass usually that is not originated from India, but when we have imported a semi-dwarf variety of a wheat from the United States, along with that this pollen grain also came to India as a contaminant, and now we have such a plants which releases this. We have such plants now in India, Parthenium and the carrot grass, that releases the pollen grain in our atmosphere. Okay, even if you see the environment prediction or the weather predictions of the Western countries, they also predict the amount of pollen grain in the atmosphere. Okay, because they are highly allergic to such kind of a pollen grain. But in India, such kind of problem does not prevail much in our country. Okay, so this is regarding to diseases which is caused by a pollen grain. Apart from that, pollen grain, they are rich in nutrients. Nowadays it is a trend that many people are consuming this pollen grain. They believe that they are rich in nutrients such that they gives a more strength to a living organism. And nowadays the tablets, syrups of this pollen grains are also available in the Western countries like the United States and the United Kingdom. This pollen grain is also going to be used by athletes, or they can also be used by the horses in the race, because it is believed that increases the strength and the power of it, because it contains or it is rich in nutrients. Third one, the next and the last characteristic of pollen grain that was remaining, and the characteristic that was remaining is that the pollen grain which is causing respiratory disorders, the pollen grain that is rich in nutrient. Now what happens once the pollen grain is released? Suppose this is an anther, and this is a filament. From that the pollen grain gets released. Now this pollen grain which is going to be released, that should fall onto a stigma. It should fall onto a stigma, the female reproductive part. Okay? Until it falls onto a stigma, it should remain a viable, or it should remain or capable of living. So how much time this pollen grain is capable of living? So the viability of a pollen grain vary from a plant to a plant species. Like in case of a wheat, in case of a paddy plant, the viability of pollen grain is 30 minutes. Means after release of pollen grain from anther, it remains viable or it keeps living for 30 minutes. Okay. Next, in case of certain other plants, like the plant which is obtained from Rosaceae family, it is plant which is obtained from Solanaceae family. Okay, in these cases, this can also remain viable for several months. Okay, until it is viable, it can able to fertilize the ovule which is present, or the female gamete which is present in the ovary. Okay, so it depends. The viability of a pollen grain depends from a plant to plant species. like the wheat plant, paddy plant, the pollen grain of such plant that remains viable for 30 minutes, and the pollen grain of Rosaceae, Solanaceae family, they remains viable for several months. Now, can we preserve this pollen grain? Yes, we can also preserve the pollen grain. If you want to preserve a pollen grain, then you should keep this pollen grain in a liquid nitrogen. This liquid nitrogen, it will provide a temperature minus 190 degrees Celsius. Remember, minus 190 degrees Celsius. That temperature is provided with the use of a liquid nitrogen. And in such cold environment, this pollen grain can be preserved. Okay? This pollen grain can be utilized whenever it is necessary, and from that a fertilization process is proceeded. Okay, so thus we can also preserve this liquid nitrogen. So the remaining characteristic I just enlist now. Pollen grain has the capacity to cause respiratory disorders like asthma and the bronchitis. Usually such kind of diseases can be caused by the pollen grains of Parthenium and the carrot grass. The pollen grain of these plants was imported to India as a contaminant along with a wheat plant or semi-dwarf variety of wheat plant. Pollen grains are rich in nutrient. Nowadays in the market, the tablets and syrups of pollen grain are available because it is believed that that causes a more that provides a more power and the strength. So that's why it can also be used by the athletes and the horse in the races. Next, the viability of this pollen grain. Once it is released from an anther or shed off from an anther, how much time it remains viable? It depends on the type of a plant species. In case of a wheat and a paddy plant, it can remain viable for 30 minutes. In case of plants of Rosaceae family and the Solanaceae family, it can remain viable for several months. You can also preserve this pollen grain at low temperature with the use of liquid nitrogen. Liquid nitrogen provides a temperature of minus 196 degrees Celsius, and that is acting as a pollen bank, and that can be utilized wherever there is a necessity. So that's all about the characteristic of pollen grain. So we have discussed the structure of male reproductive part of a flower, that is a stamen, anther, microsporangium, and we also have discussed regarding the process called as microsporogenesis and the process of development of male gametes. Okay, apart from that, we have also seen the structure of a pollen grain and their characteristics. Okay, now similarly we also have to learn the parts of a female reproductive part of a flower. The male reproductive part has been finished, and we have discussed how the male gamete is produced, because in the pre-fertilization the first step is the formation of a gamete. So we have seen how the male gamete is produced within a pollen grain. Okay, now we have to discuss how the female gametes are produced. Okay, and to learn that we have to learn the female reproductive part of a flower. Okay, so let's start with the female reproductive part of a flower. As you already know that I have repeated several times, Androecium is male reproductive wall of a flower. Similarly, the comparable organ of female reproductive part is a gynoecium. So what is a gynoecium? Gynoecium is female reproductive wall of a flower. It is a female reproductive wall of a flower. The individual unit of gynoecium, it can be called as carpel, or it may be called as pistil. Okay. So what is another name of this? Or carpel? The carpel is called as pistil. What's the individual unit of gynoecium? The individual unit of gynoecium is called as carpel or pistil. As you know that stamen can also be called as microsporophyll. What is another name of stamen? Microsporophyll. Similarly, the carpel or pistil can also be called as Megasporophyll. Okay, what's another name of carpel or pistil? It's called as a Megasporophyll. Okay. Now, This carpel or pistil, it's an individual unit of a gynoecium. How many carpels are present in a plant? The number of carpels present in a gynoecium or the bulb or in a flower, that may vary. If it possesses one carpel, the flower possesses one carpel, only one carpel. Such kind of flower is called as monocarpellary. Okay? If there are many carpels, then it's called as multicarpellary flower. Or it can also be called as polycarpellary flower. Clear? So based on the number of carpel, the flower can be divided. Okay, actually it is divided into three parts. If it possesses one carpel, then it's called as monocarpellary flower. If it possesses two flowers, then it's called as bicarpellary flower. And if it possesses many carpels, then it's called as multicarpellary or the polycarpellary flower. If there is a one carpel, then there is no problem of a fusion or the separations. But when there is a multicarpellary flower, the carpels may be fused, means they are attached with each other. Many carpels, they may be attached with each other, or they may be free. If it is a fused or attached, this carpel remains a fused or attached, then it is called as syncarpus. And if it remains free, then it is called as apocarpus. Clear, student? So what is a syncarpus? Syncarpus is a flower in which carpel is fused, and the apocarpus is a flower in which the carpel remains free. Okay, that is the case in case of multicarpellary or polycarpellary flower. Now let's discuss the different parts of a carpel. What are the different parts of a carpel or pistil? The carpel or pistil, that's divided into three parts. The first is called as stigma, second one is called as style, and the third one is called as ovary. What we have discussed in the first session, which are the different parts of a carpel or pistil. There are three parts of a carpel or pistil: stigma, style, ovary. So let's start with the structure, or I draw a structure of a carpel or pistil. The first part is a stigma. Second part, which is like a tube-like. This tube-like portion is called as style, and the last, a bulged portion, it's called as ovary. So this is a portion what we call as stigma. Next, a tube-like structure, what we call as style, and the lower one, bulged portion, it's called as ovary. I have drawn just one carpel. This is a structure of one carpel. The stigma, that is a terminal part of a carpel or pistil. It serves as a landing platform of pollen grain. Pollen grain falls on it. It can accept. So that's why the structure of stigma is such that it has a grooves. Within it grooves, that pollen grain might get attached, okay, or that remains suspended within this groove. So that's why it has a groove-like structure. So the stigma is serving as a landing platform for pollen grain, where the pollen grain falls. Okay. Next, the tube-like structure which is attached with it, it's called as a style. And the lower one, the bulged portion, it's called as an ovary. Okay. Now within an ovary there is a cavity. This is a cavity. Okay. This is called as ovarian cavity, or it can also be called as locule. Let's say this is a cavity. Okay. Within that there is a presence of an ovarian cavity, or this ovarian cavity can also be called as locules. This ovarian cavity or the locules, it contains a presence of placenta. What it contains? Placenta. Okay, such placenta is present, and from this placenta the ovules are attached. So these are the ovules. Ovules are attached. Okay, this is an ovule that is attached to a placenta by a stalk that we will discuss. This ovule can also be called as Megasporangium. What's another name of this ovule? It's called as Megasporangium. I can repeat the structure of ovary. Ovary contains a cavity. This cavity is called as ovarian cavity. That contains a placenta. This is a placenta. Okay. The placenta that is attached with a ovule. Ovule is also called as Megasporangium. Okay. The ovule is attached to a placenta by a stalk. Okay. That is a basic structure of carpel or pistil. Now if you see the number of ovules, see 1, 2, 3, 4, 5. Here I have shown the 5 ovules. Okay. But it is not necessary, it is a 5, 2, 3, 1, etc. But the number of ovules within an ovary may vary. Some plants are such as that, or some fruits are such as that has just one ovule in a one flower. And there are also examples which has many ovules. Like the examples which has only one ovule. Like for an example, mango. If you see a mango fruit, it has only one seed, because that seed is formed from a ovule. Why it has only one seed? Because it has only one ovule. Okay, so this is a mango plant, it has only one ovule. Next, a wheat. Next, paddy. These are the examples in which the ovarian cavity possesses only one ovule, and hence they only have a one seed. Now there are also examples which have many ovules. Like for an example, papaya. Or you can see a second example, watermelon. Okay, these are the example. If you see a watermelon or the papaya, there are lots of seeds are present in this watermelon and the papaya. Why it has a lots of seeds? Because it has many ovules. Because you know that ovules are converted into a seed. Ovary, remember, ovary when it is fertilized, it converts into a fruit. Ovule when it is fertilized, it converts into a seed. So when ovule gets fertilized, it leads to a conversion of seed. So if it has many ovules, so how many seeds are produced? Many seeds are produced. If it has one ovule, how many seeds is produced? That is only one seed is produced. So these are the example in which there is only a presence of one ovule, like mango, wheat, paddy. But we also have examples which has many ovules and hence they have many seeds. Like for example, papaya and the watermelon, they have many ovules within an ovary. Okay. So that is about a basic structure of a carpel or pistil. Okay. Now we have to see the process, what we call it as formation of female gamete. But for female gamete we have to learn the structure. So we have seen the structure of carpel, stigma, style, ovary, and ovary contains a ovule, what we call as megasporangium. So now let's discuss the structure of megasporangium, or we also call it as ovule. So now we start with a structure of ovule. What is another name of this ovule? Ovule can also be called as Megasporangium. Okay, before I start, I want to make you remember or remind you the different names. What is another name of stamen? Stamen is called as microsporophyll. Okay, what is another name of carpel? The carpel is called as megasporophyll. Okay, the stamen produces microspore. Okay, the carpel produces megaspore. Stamen contains microsporangium, usually circular in outline. Okay, that the structure of it what we have discussed in the previous session. Now this one that contains, or the carpel contains megasporangium, what we call it as ovule. Okay, now we have to learn the structure of this ovule, or you can also call it as megasporangium. Okay, what is an ovule or what is a megasporangium? How it look like? You know that this is an ovule. This ovule is attached with a stalk-like portion to a placenta. That much information we have now. Why we call it as ovule? because usually it is oval in shape. Clear? That's why we are calling it as ovule, or the other name of this it's called as Megasporangium. Okay. Now you know that this ovule, this is the ovule that is attached to a placenta by a stalk. So I will draw stalk in an enlarged view. This is a stalk. Okay, by a stalk it is attached. Okay, so the stalk-like portion by which it is attached to this is a placenta. Assume that this is a placenta. Okay, so this is a ovule. Ovule is attached to a placenta by a stalk. This stalk is called as funicle. Okay, clear? So what is a funicle? The ovule is attached to a placenta by a stalk-like portion. This stalk-like portion is called as funicle. Okay. Next, this funicle attaches to a ovule at a certain part of a ovule. This part, a part of a ovule where the funicle attaches. Say this is a part of a ovule where the funicle attaches, or this portion is called as hilum. What's called as? It's called as hilum. Okay, students. So here it is ovule. Ovule is attached to a placenta by a stalk. This stalk is called as funicle. Funicle is attached to ovule in a certain region of ovule. The region where it attaches, this is called as hilum. Okay. Now this ovule that is surrounded by two layers. There is a presence of two layers. Okay, that is surrounding to it. The layers which is surrounding to ovule, this is called as integuments. Clear? What is called as integument? But there are two layers. The outer one is called as outer integument. The inner one is called as inner integument. Okay, so how many layers surrounding to an ovule? So the ovules are surrounded by two layers. The layers are called as integuments. The outer one is called as outer integument. The inner one is called as inner integument. Okay. At a certain part where there is an integument is absent. See, this is a portion where the integument is absent. Covering is absent. Okay, integument is the covering of a ovule. That integument absent, and this portion, a pore-like structure is formed. A hole-like structure is formed. This is called as micropyle. What's called as micropyle? Okay, or you can also call it as apex of ovule. What it is called as apex of ovule. Okay, so what is a micropyle? Micropyle is a portion of ovule where its covering is absent or the integument is absent. This is called as micropyle. Okay. Now inside the covering, this is the inner portion of a covering. What it contains? It is known as nucellus. What it is called as nucellus. The inner portion of this integument, inside the integument or covering, inside a covering, what is present? Nucellus. Remember, it's not a nucleus. This is nucleus. It is not a nucleus. It is nucellus. Okay, so it is a nucellus. This nucellus is filled with reserve food material. It's filled with a reserve food material, and that is utilized by developing embryo cell or the female gametophyte. Okay, so this is a nucellus. Now inside a nucellus there is a presence of embryo sac. What it is? Embryo sac, or you can also call it as female gametophyte. Okay, pollen grain is male gametophyte. Similarly, the embryo sac is female gametophyte. Okay, so this is about a structure of this ovule. Okay, one thing is left. You know that there is a region where the covering is absent or integument is absent. This is called as micropyle, and that forms the apex of ovule. Its opposite end, its opposite to this micropyle, this one. This is a end. This end is called as chalaza end, or its opposite, base, which forms the base of ovule. Micropyle forms the apex, its opposite is a chalaza, chalaza forms a base. The opposite part of a micropyle is called as a chalaza. Okay, so the micropyle and the chalaza, they are present into opposite direction. Okay, so that's all about the structure of ovule or microsporangium. I again repeat, you have to remember it very clearly. Okay, so what is the structure of ovule, or you can say a megasporangium? Ovule is called as megasporangium. Remember, usually ovule is oval in shape. This ovule is attached to a placenta by a stalk. This is a stalk. This stalk is called as funicle. This funicle attaches to a ovule in a region of ovule. This region is called as hilum. Ovule is covered by a covering. How many covering? Two covering. One is outer integument, the another one is inner integument. Okay? But there is a place where there is a absence, or there is no presence of covering or integument. This region is called as micropyle. This micropyle forms the apex of a ovule. Its opposite end of a micropyle is called as chalaza, which forms a base of a ovule. Inside an integument, there is a presence of nucellus. This nucellus is filled with a reserve food material, and that is provided to this embryo sac for its growth and development. Okay. Next, inside the nucellus there is a presence of embryo sac. Okay. So that is about the structure of megasporangium, or you can call it as ovule. This is an important part. Okay. So all of you should know the structure of this ovule or megasporangium. And inside this megasporangium, what we have? We have an embryo sac or female gametophyte. So now we have to learn how this female gametophyte is formed, and that is by a process. By which process it is going to form? So let's discuss the process by which it is going to form, or how the female gametophyte develops. Megasporogenesis. Megasporogenesis, you already know the meaning of genesis. Now I don't have to tell you what is the meaning of genesis. Genesis means a formation. Formation of what? Megaspore. The formation of megaspore is called as megasporogenesis process. Okay, so here a megaspore is formed, and this megaspore is finally developed into a female gametophyte, or what we call it as embryo sac. Okay, how it occurs, that we will see. But before that, we have to see the formation of megaspore, because once the megaspore is formed, then the female gametophyte or embryo sac is formed. Okay, so first we will learn a process called as megasporogenesis. So what is a megasporogenesis? It is a process of formation of a megaspore from megaspore mother cell. What we call it as MMC, shortly called as MMC. Megaspore mother cell. Okay, so a formation of megaspore from megaspore mother cell. This process is called as megasporogenesis. This megaspore formation can be achieved by a process called as meiosis. Which process? Meiosis. Okay, so let's see. This is a megaspore mother cell. So I draw just a megaspore mother cell. This is a megaspore mother cell. It is a diploid in nature, means it contains a 2n number of chromosomes. It divides by which process? Meiosis. So you know that meiosis forms how many daughter cells? 4 daughter cells because it's a characteristic of a meiosis. Okay, and you know that at the end of meiosis process, the daughter cell which has generated that contains haploid number of chromosome, or you can say that n number of chromosome, and this is what it is going to be formed. These are called as megaspores. Okay, so simple one. It's a process of formation of megaspore from megaspore mother cell. How it occurs? A diploid megaspore mother cell. Remember, what's a ploidy of megaspore mother cell? It is a 2n diploid. It undergo which process? Meiosis, and it generates how many? 4 haploid, means n containing megaspore. This process is called as Megasporogenesis. Okay, so one megaspore mother cell generates how many megaspores? 4 megaspore is produced. This is called as Megasporogenesis. Clear, students? So that process is called as Megasporogenesis. Now what happens to this megaspore and how the embryo sac or female gametophyte gets developed? So let's move ahead. So I briefly just enumerate. This is a 2n megaspore mother cell. It divides by a process called as meiosis. How many megaspores are formed? Yes, 4 megaspores are formed. Each contains how many number of chromosomes? Half the number of chromosomes than the parent cell, because it's a meiosis process. These all are megaspores. So one megaspore mother cell generates 4 haploid megaspores. Now what happens to this, or how the further process occurs? Now you know that 4 haploid megaspores are produced from one diploid megaspore mother cell. From these 4, okay, 3 will degenerate. Okay, that means they get destroyed. From 4, how many gets degenerated? 3 gets degenerated. Only 1 gets left. Okay, so I just keep over here. This is a megaspore. Once after destroying whatever the megaspore that is left, any one gets left because all are equal. Okay, this is called as functional megaspore. Okay, so what happens to these 4 megaspore? From the 4 megaspores, that is generated from megaspore mother cell, 3 will degenerate when the development starts. Only 1 gets remain, any one gets remain, and the one that is remain, that is called as megaspore, or you can also call it as functional megaspore. From this functional megaspore, the embryo sac develops, but only from one functional megaspore the embryo sac development occurs. So such kind of development is called as monosporic development. Okay, so what is a monosporic? Mono means a one. Development of embryo sac from only one functional megaspore. This is called as monosporic development. Okay, now you know that this is a functional megaspore. What happens to it? This functional megaspore, the nucleus which is present in it, this is the nucleus which is present in it. Okay, this is a cell, functional megaspore. It contains a nucleus. Nucleus contains an n number of chromosomes. Okay, now they divide mitosis. They divide by a process called as mitosis. Okay, mitosis means how many daughter cells are produced? 2 daughter cells are produced. So it divides by mitosis by, I just draw a nucleus. Okay, it divides by a mitosis, and how many daughter cells are produced? 2. That again go under a mitosis. Okay. Then again undergo mitosis. So this is a mitosis. This is again a mitosis. Mitosis. Okay. Every time two daughter cell is produced, because it's a mitosis process, and as it is a mitosis, it contains the same number of chromosomes as the parent. Parent has an N, so obviously all contains a N number of chromosomes. Only in meiosis the chromosome number gets half. In mitosis the chromosome number remains the same. So the functional megaspore is formed. How it is formed? You know that 3 will degenerate, only 1 gets left. That is called as functional megaspore. This functional megaspore, they enters into a meiosis, or they divide by a mitosis. Okay. How many times it undergo mitosis? It undergo mitosis 3 times. 1, 2, 3 times successively. So when it enters mitosis first time, 2 nuclei are formed. Second time, total 4 nuclei are formed. And when third time, total 8 nuclei are formed. Remember, this functional megaspore now enters into a mitosis 3 times successively. And at the end, how many nuclei gets formed? 8 nuclei gets formed. How many nuclei gets formed? 8 nuclei gets formed. I just draw 8 nuclei over here. These are the 8 nuclei is going to be formed, because the process occurs over here. Okay, and then ultimately embryo sac formation occurs. Okay, now this 8 nuclei gets formed. See, this is a kind of a mitosis. Usually a mitosis, in mitosis first a nuclear division occurs, means nucleus gets divided, and then what divides? Cytoplasm divided. But here the mitosis what occurs? That is free nuclear mitosis. What is a free nuclear mitosis? Free nuclear mitosis means it is a type of mitosis where nucleus divides, but the cytoplasm does not divide after a division of a nucleus. So only nucleus divides. Only nucleus gets divided. Cytoplasm does not divide. So how many nuclei came into existence? 8 nuclei came into existence after a 3-time successful division. Okay. Now what happens? These 8 are over there. Now you know the end. This end. The end towards the micropyle is called as micropylar end. The end towards the chalaza, this is called as chalaza end. This nuclei gets organized. Remember, each one has a haploid number of chromosome, but I don't have a space over here to write. So I just organize. 3 nuclei are arranged at micropylar end. 3 will arrange at chalaza end. And the 2 nuclei, it remains in the center. Okay, I again repeat, from 8, this 8 nuclei which is going to be formed, 3 will be arranged at micropylar end, 3 will be arranged at chalaza end, and the 2 will be in center. Total 8, finish. So 8 nuclei comes into existence. Now it becomes a mature. This nuclei develops a cell membrane around it. Okay, they develops a cell membrane around it. Okay, so now what happens? This 3 nuclei or 3 cells, these 3 cells and these 2 nuclei, they combines together. So N plus N combines together form 2N, and these all are N. Right? So you can come to know. It's very difficult to observe, but they are all are haploid. Okay, so 3 cells are present at the micropylar end, 3 cells are present at the chalaza end, and the 2 cells which were in the center, now it combines. Remember, here there are 2 nuclei, N, N. Now they combine during the development, N plus N, they combine together and form a 2N. Okay, so at the maturity, how many cells? 8 cells. 3 plus 3, 6, 6 plus 1, 7. Now 8 cell converts into a 7 cells. Okay, and here the 2 nuclei gets converted. So this condition is called as 8 nucleate. But how many cells? 7 cells. Okay, how this process occurs, I again repeat. Initially we have 8 nuclei. How we have 8 nuclei? 8 nuclei which is formed at the end of 3 mitosis for functional megaspore. from this 8 nuclei, 3 arrange at micropylar end, 3 arrange at chalazal end, 2 remains in the center. Okay, so total 8 nuclei. This nuclei converts into a cell. Okay, but that means during the maturation process. During the maturation process, the 2 nuclei which is present in the center, they fuse together. And now it becomes only one. So each one contains N. Now by fusing it becomes a 2N. Okay. So here it's a 7 cell. 3 plus 3, 6 plus 1, 7. And how many nuclei? 8. 3, 3, and here 2 gets fused. So 8 nuclei. So this condition is called as 8 nuclei and 7 cells. This is very important. Okay, regarding the examination point of view. And they are usually asked at the maturation, how many nucleus? 8 nucleus, but how many cells? 7 cells are going to be produced. Which 7 cells? What are their names? You know that 3 cells are at the micropylar end, 3 cells are at the center, and the 2 or they fused in the center. Okay. The 3 which is at the micropylar end, what are they? The 3 which is present at the micropylar end. From that, one is egg cell. One, remember, one egg cell, and these 2 are synergid cell. All of you know that how many nuclei are present at the micropylar end? 3 nuclei or 3 cells are present. From 3 cells, which 3 cells? One egg cell and 2 synergid cell, which combines together and it forms egg apparatus. What it forms? Egg apparatus. Egg apparatus is present at which end? Egg apparatus is present at the micropylar end. What the egg apparatus contains? Egg apparatus contains one egg cell, means one female gamete, okay, and 2 synergy cells, total 3. Okay, this is most important question. I again repeat what the egg apparatus contains. Egg apparatus contains one egg cell and 2 synergy cell that is present at which end? Micropylar end. Now the 3 cells which is present at the chalazal end, these all 3 cells which is present at the chalazal end, they are called as antipodal cells. So what is antipodal cells? The antipodal cells, they are present at the which end? They are present at the chalazal end, a base. And in the center, what is present? This is the center. That is present is called as polar nuclei. It's a polar nuclei. Okay, I again repeat. At the micropylar end, egg apparatus is present that contains one egg cell, 2 synergid cell. Second, at the chalazal end, how many cells are present? 3. All these 3 cells are called as antipodal cell. In the center, the 2 nuclei combines together and they are considered as polar nuclei. And thus, there is a formation of embryo cell or female gametophyte occurs. So that's all about how the female gamete or egg cell gets produced. Egg cell means a female gamete or embryo cell formation takes place. Okay. So in the previous session we have seen how male gamete is produced. In this session we have seen that how female gamete is produced. You already know that gametes are haploid. So male gamete produced is haploid. Female gamete also produced over here is a haploid. Okay. But how many male gametes are produced? 2 male gametes are produced. And how many female gamete is produced? 1 female gamete is produced. Remember this information because we have to apply this in the next during the fertilization process. So today we end here. We have finished with a first process in pre-fertilization. It is gamete formation, gametogenesis. Male gamete is already formed. In the previous session we have formed it, and in this session we have learned how the female gamete is formed. The gametogenesis is formed. Now the second step in pre-fertilization, and that is gamete transfer. Gamete is formed. Male gamete is formed in the stamen, female gamete is formed in the carpel. Now the male gamete has to be transferred because usually male gamete is motile and female gamete is stationary. It has to be transferred. But here it's an angiosperm. Both are non-motile. Okay? Even pollen grain, or you can say male gamete cannot move. Then male gamete is present in pollen grain. Female gamete cannot not move. So there is a need of agent which will transfer a male gamete to a female gamete, and that what we call as pollinating agent. So in the next session we will learn the pollination process, means how the transfer occurs, what are the different ways of transfer, gamete transfer, okay, and who will helping in that transfer process or gamete transfer process, means you can say that which agents they will help in that process, what we call it as pollinating agents. So that's all about it. Today's session we end it over here. Today's session. Thank you for watching. Keep learning. Subscribe this channel, and thank you for watching again. Just have a look for few times.